Okay. All right, we're live now. All right. So, right. So, I'll open up KPNG, the pull request on this side over here. So this is a, let me put the thing in here, Windows KPNG PR and setup. All right, I'll just put it in here in case someone's watching. All right, cool. So, and this is just on the Antria YouTube channel, so it's just networking, hacking stuff. So it's not an official CNCF meeting or anything like that. I'll put the pull request over here, Windows kernel space that we have. Okay. And so this is mostly compiling now. And on the right over here, I'll put sort of the instructions that I have on how I test it. And you can use this. You can totally use this workflow, Dimitri. So what I do is I compile, right? You just get Golang 18 and then you just clone down this pull request and then you just run make Windows. Okay. So that's not a hard thing to do. Like I could probably just do it here, right? I could just cd.
This is on a Linux host, right?
Yeah, and I only do it on Linux because when I do it in when I do this in yeah, here we go. So I just run make Windows, right? Oh, git stash, git pull. Here we go. So let me pull down the latest, right? And then you should just be able to do make Windows. Okay, looks like somewhere Matt might have pushed a compile error. So let's see what he did. Backends. Vim /backends Windows kernel space endpoint. What is that? Any? I don't know what that any function is. So it looks like this is recently something like some whip code.
The commit message literally says doesn't work.
Yeah. So we're going to have to ask Matt where the hell we got this from. So we can git blame this, right? Git blame. Okay. Okay, so looks like Matt added this any in here, but he didn't commit the file that had the any in it. Okay, so let me ask Matt. Matt's my friend. We can yell at him. Any. Let me see here. What's this any function? Okay, so let's just back this commit back a little because this probably we don't probably need this. What if we do here git check out that one and let's try this one. Oh, he still got it. We can go to mine. We can go to this commit. Okay. Now I bet this will work. Oh, that's weird. Git reset -- hard. Git log. We'll just keep going back. git checkout. Okay, now let's try that. Make sure I have the right Golang version here. There we go. Okay, so this is Golang 118. You need to make sure you have that. Okay, so now this is going to compile and like ultimately once it's done compiling, you're gonna get a binary, right? And then if I do cd source, have you heard of Sig Windows DevTools, Dimitri?
Yes.
Okay, so that's what we use for our development environment, right? So Sig Windows DevTools just makes a Windows cluster for you, and it's like hackable. So I can do like Vagrant SSH. Let me see if I can get in here. Okay, so I can get into my Windows node, right? And then if I look in this Windows node, I don't see the I don't see it. So, but it's okay. I don't need it. I can go and I can then go and I can what I do is I compile it on a remote Windows box and a remote Linux box. And then once I compile it, I just curl it down like this. Okay. So then I just literally will curl it just like that. Okay. And then after I curl it, I will simply just start it up like this. Okay. So /KPNG Windows, and then I'm just gonna do this guy right here, right? Oh, what did I do? I don't think I have a running Windows cluster in here. Like, I don't think I have
what you curled was the the compiled Windows binary that you generated earlier using make Windows, right? You upload it to a Google storage bucket or something.
Exactly.
Okay.
Exactly. So I pull this exactly. So I curl that down and I upload it to a Google storage bucket. And I just do that because for some reason when I try to compile this Windows executable on my Mac, it doesn't work, and I don't know why. But I can compile it in Linux, right? So then what you do is you pull that down and then you just run these two commands. You create these new network firewall rules. And these I got from the Calico installation, because Calico, when you install the Calico kube proxy in kernel space, it does these two commands, okay? And this sort of sets up your new HNS network. So I just literally run these, I copy paste them, and I just run them in the terminal. So I'll just like run this one. Oh God, it didn't like that. Maybe it's the coloring or something. Okay, see, so I did that, and then I'll run this one, and I'll create this one, right? Oh, Jesus.
I think there is an import module comment somewhere.
Oh yeah.
By the way, we have
you have to
a newer HNS PowerShell module published on the PowerShell gallery.
Oh, really? Okay. Yeah, we probably should.
Let me give you the command.
I think it's install module name HNS.
Can I do? Is there a way? Yeah, if you give me a command, I'll run it. I don't know. What?
Here.
You can put it here in the comments.
Yep. Try this one.
Yeah.
Okay. All right, install module -name HNS. That's easy. Oh, that's great. I didn't know I could do that. Let's
The
update this
first
blog
command I
post.
pasted will overwrite the old one if you have it.
Where is my... Here we go. But wait. Okay, cool. I'm updating this blog post. So, okay. All right, so we're going to do this NuGet thing. We're going to install that. And then once that's up and running, right, then the next thing we're going to do... What happened?
I think you pressed enter, like the default does now.
Okay,
yes,
I'm
try
assuming that
the command that I gave you.
Yeah, the allow clobber one.
Yeah, if you
Yeah,
have it,
right.
you have an old one. It will basically complain that some of the names of the PowerShell functions already exist. They're conflicting. Won't know which one to pick. This one should force the
Okay.
installation as module. And do a maybe yes to all.
Okay, cool. There we go. So now that worked. Oh, this is new. This new subnet policies. So that doesn't work anymore, I guess. Did you change that?
Yeah, there were a few changes there. Subnet policies required.
I mean, maybe it's not required. I don't know. I could just get rid of this.
I actually think those are required. I have the same requirement for Flannel when installing.
Okay.
Let me check.
In any case, I mean, it's not, this isn't critical to what I was going to show you anyways, because I was going to show you how to run KPNG, right? So this is Windows stuff. I'm sure you all can figure it out. So now let's go here, cd source, sig Windows DevTools, and let's now vagrant SSH control plane. Okay. So now I'm in the control plane, and what I'm going to do is now run the Linux binary. And this is the part that I really needed to show you. Like, so to run the Linux binary, we got to do one of these. Okay, we're going to get it. Okay, and I'm going to chmod 777, that KPNG. Okay, and then in here, right? Now I'm going to run that executable. So can you see that executable that's running there?
Yeah.
Yes.
Okay, so that is the, there we go. So that's the, how do I get this command to end? It like won't end. Jeez, what did I do? I have a better idea. Let's do these both in the same terminal. So let me rerun that command I just ran. okay, up here, and then let me SSH vagrant at 10.20.30.11. Okay, and so now I'm in the Windows at the bottom, right? So the Windows is at the bottom and the Linux is at the top. Okay, and so now I can start the Windows proxy. And what the Windows proxy will do is it'll come online and then you're going to do this. I'll make this big font so it's easy to remember. Okay. I'm going to put that in orange so it's easy for us to remember it. Okay. So then we do this last part. And this is the thing that this is really the only thing you needed to know is you start this, but you don't give it the TCP. You give it without the TCP. Okay. There we go. Okay. So now you're running it, right? So now what's happened here is, oh, we didn't set the kube network. So I can say like kube network equals whatever the name of the network was, external, I guess. And maybe then I can just run this. How do I export it? Do I just do, can I do export?
You're trying to set the variable?
Yeah.
I think if you just do a dollar sign in front of kube network, would that work?
Like that?
Yeah, and then equals. Put it in a string, maybe. Like in quotes, yeah. Wait, can you print kube network? Just run kube network with the dollar sign.
Yeah.
Does it?
Well, it's definitely there.
Does it need a network flag or something?
Environment variable kube network and network flag not initialized. So let's look in the code and find that network flag. This is really weird.
You could also try like this.
Here it is right here, HNS util. Oh, so this doesn't like that. It
Do we
doesn't
have
say...
a network?
Oh, we don't have a network. So it's saying that this is failing, so that environment variable isn't set. Is it
Yeah,
like
that
set
is what it's saying.
set? Can I do set env or something?
I think.
Try with the $env quotes and put a variable name afterwards.
Yeah, like this, right?
Yeah, you're right.
Yeah,
you're right.
exactly.
Now it'll work.
But have we created the network? I think that's.
We didn't create the network, but that's the whole workflow. So I'm just going to update the blog post. So I mean that's it though, right? So you do that and then you.
That IP address and port was the KPNG instance you launched on Ubuntu on the Linux host, right?
Or
was it your API server? Like you're passing in
this.
a
So what this is doing, what's happening now, okay, let's kill this so you can see what's actually happening, right? So what's happening is this is serving a gRPC endpoint up, okay? And that gRPC endpoint, similar to kind of, I explained a little bit of this, I think, yesterday, I don't know if, did I? So what it's doing here, okay, is KPNG takes everything in the API server and then makes a single YAML hierarchical representation of the Kubernetes network space, okay? So it makes this, right? So I'll make some. I'll put some notes at the bottom of this, okay, on how it works. Okay. So how it works. Okay, so Linux gRPC representation is that, right? So this file sort of represent, and then what's going to happen is so what then happens is this code here, right, is going to then go into this sync.go. And the sync.go is the Windows backend. And the sync.go, every single time that there's a new endpoint created or deleted or a service is set or a service is deleted, the existing in-tree kubectl in-memory code is then sort of wrapped and triggered from KPNG. And so the kernel space that you're used to working on will make sense from here on down. Does that make sense? That's kind of the most important thing to understand here, Dimitri, is that like this sync.go is the thing that connects the KPNG to the old kubectl logic.
Okay.
Right?
So basically we don't have an async runner that will run 30 seconds. The sync will be triggered by these four methods.
Yeah. These methods will trigger the service changes, and there's no watch on the API server. Instead, when something changes, KPNG, this Linux process up here, will talk over gRPC, and the Windows process here will find out over gRPC that something changed. Okay? And then the specific data model for those is the local VNet 1 service, right? And the local VNet 1 endpoint. Okay? And so then those will get sent in. And then everything else will look basically the same. And you might be saying, well, why are we doing the same thing? And the reason is because as a V0, just to get the ball rolling with Windows, what I did is I took the old kube proxy and I copy pasted it into KPNG so that KPNG could call out to it so that we could show that it, we could sort of get things going. But in the future, at some point, what we really want to do is to use the full power of the KPNG data model and to do what NFT does. Because in the NFT implementation, rather than using this set service and set endpoint, okay, it does a much more powerful thing, which is that it sends the entire networking data model directly over gRPC every single time. And it has logic in it. Where is the implementation? Here it is. You see this, Dimitri?
Yes.
Yeah. Okay. So this service endpoints, this does essentially the same thing, but what it does is it takes this entire data structure, all of these all these endpoints, and it sends them in. And then every single time anything changes, all the data is updated. And then you don't need any of these caches or anything else. And it turns out that this is actually very performant when you do it over gRPC. And this means that this is a much more elegant implementation of the KPNG proxy, because you're not reusing the old code from the old proxy. That said, once these I feel like it's not a lot of work, especially if you understand the Windows networking model the way you all do. I feel like it's not going to be too bad to finish getting the Windows proxy working. And then at that point, we can sort of say, okay, now we, at some point for the future, we want to rebuild the entire Windows proxy to use this pure gRPC state. That's probably what we're going to do with IP tables. The first thing we did with IP tables, because it's the most common implementation of kubeproxy for Linux, is we just took all the logic from the old proxy and put it in there just so we could really show that all the tests pass. And then now people are starting to sort of think about like, what's the next, when are we going to be able to make the IP tables implementation truly modernized with the full-blown sort of stateless KPNG implementation. So the overall architecture, I probably didn't, this might be your first time to see the KPNG stuff, so I'll show you the overall architecture. I kind of forgot to explain to you is that what we have is we have this global data model, which is this thing over to the left here, and that thing is derived from the API server. And then it sort of aggregates the services and endpoints into this really easy to reason about data structure. And then that data structure is then sent down to these backends. So what I just showed you was the Windows kernel space backend. And so that's called a sink, right? And so that code then flows into the backend. And then the backend goes and writes the IP tables rules, right? Or the Windows networking rules, right? So the backend, in other words, is down here. And the sort of global data model is here, right? So the backend is communicating to this one. And this is pretty easy to do in this Vagrant setup because the IPs are hard-coded. 10.20.30.11 is going to be your IP address of your Windows node. So you could see the Windows node is checking in, and 10.20.30.10 is the IP address of the Linux node. And when you run the SIG Windows DevTools, you just run, all you have to do is sort of comment out the CNI part because you don't want to install Calico when you're testing this because Calico will try to install its own kubeproxy. So you comment out the CNI part and you just do make all, and then it will spin up a Windows cluster with 2 nodes on it, and then you can sort of manually install the KPNG bits. So yeah, I mean that's the whole setup really. And so now, if we go back here. Now, if we go, let's see. If we go back to that post, that has the workflow in it, right? So this then, so you do this, and then you do make all. I should have put make all in here, right? Yeah. Cool. There you go. Okay. Exactly. So you comment out the CNI parts. You could also do like flannel as your CNI, and as long as flannel isn't starting kubeproxy, that might work too if you wanted a CNI. In my experience, you don't need a CNI because you can test the kubeproxy without a CNI, right? Because if you can get Cordia and SN points being written on that Windows node, right, then you know that the proxy's working, and you don't need a CNI in order to do that because your Linux CNI is working, right? You do have the CNI, you do have endpoints. You do have, you can run the Linux CNI easily, right?
Okay, and it's unclear to me. So right now the Win kernel does not work, or is not fully implemented.
No, yeah, it's not fully working right now. So there's this compile error, and I'm sure Matt will fix that. Oh, he can't join. No problem. But Yeah, right now it's not. Yeah, right now it's not. It's not fully working yet. So, in fact, not only is it not fully working, but Matt fixed pushed a break to it, something that broke something. So, so that's kind of where we're at, though. Where we're at is that we have it compiling, we have it building the Windows binary, we have it connected to the KPNG backend, but it's not yet writing the Windows networking rules out. It's not making the calls to the HNS API to write out those Windows networking rules yet. And normally this works. So I'm kind of surprised that like that HNS network thing that I tried to do didn't work. Maybe, see, this just hangs. So this is a new module. So maybe we really do need to use maybe we should just use this one, right? Because I think this works.
Yeah, the old one will work with the old, whatever command that Calico used, because they're using the old one.
Yeah.
If you want me to, I can confirm the new HNS network command with the new HNS PowerShell module.
Well, I mean, I'm for the purposes of this, I think it's just showing you all how to run the KPNG stuff. So I don't.
Yeah.
I'm not worried about.
Interested. Okay.
Yeah, I think we definitely will want to solidify that for sure. But right now I have a development environment that I can run, and as long as you have one that you can run, I think all that really matters is that we start sort of hacking around on this. So, I mean, that's pretty much where things stand right now, and like the bulk of the work at this point, I think, is just having someone to own it that is really deeply invested in the Windows networking side full time, kind of. And because what we need to do, which is what we had to do with IP tables, right, is we just need to make sure that we plumb in the details of the implementation correctly, because the fundamental thing that happens when you do a KPNG proxy, that you don't have this problem with the existing kube proxy, right? Because it's already been solved in the existing one. The fundamental thing is really simple. What we need to do is we just need to make sure that sync.go. How did I get into this view? Sorry about that. We just need to make sure that like this, for example, when you set an endpoint, right, this local VNet endpoint, that's going to have some HNS metadata associated with it, right? Because you're going to make an API call to HNS to create an endpoint, and then that endpoint will have like a hash, right?
Yes.
Right. So the KPNG doesn't model that Windows specific data, right? And so since that model it's bringing in the abstract model of a Kubernetes endpoint, right? Since it's bringing that in, what we need to do is just make sure that when we grab those HNS IDs, just like we do in the existing kube proxy, we just need to cache that data. So I've done some initial caching of it in a map or something stupid like that, which we could rethink. And it'll become very obvious to you once you start going through the code, because you'll look at this endpoint update and you'll see what that calls. And then once you see what that calls, it'll be kind of obvious that that's calling. You'll see the endpoint update calling, and then that ultimately calls the update pending or whatever. And at some point, once that update is pending, as you know, the endpoints will get like periodically written back out, because this, from here on down, it just follows the same logic as the existing proxy, right? So it'll write that out, and then I think I wrote a function called like write, like, or save or something like that. Where is it? I mean, I guess we could just look for new yeah. Here we go. create endpoint. Yeah, okay. So here's where we create the endpoint. And so we have this new HNS endpoint. And
This is like the sync proxy rules function
yeah,
in the legacy proxy.
exactly. We were reusing that, right? And
Yeah, we wanted to like the part of the items that Dimitri was looking at was simplifying this whole huge blob
yeah,
of the sync proxy rules, because it's like very long and it's not really well coded necessarily.
yeah,
We wanted to refactor all of this to improve it.
yeah, exactly.
Then we wanted to take the improved, the core logic of kproxy into KPNG. That is what was our goal, kind of.
Yeah, and so, and another way you could look at this entire problem space, right, is you could say, okay, like we want to rewrite this anyways, so you could just start with the if you're more interested in actually re-architecting it, I think this is a great opportunity to do that, right? Because you could start with the sync.go, right? And you could literally just implement the functions from here on down on your own.
Mm-hmm.
And that would be great. And that gives you the opportunity to completely rewrite the Windows kernel space logic proxy from beginning to end. And if that's something that you're considering, which is exactly what the NFT implementation does, then rather than looking at this Windows implementation, you could just sort of take the workflow that's here and you could really look and implement the NFT implementation and copy that as the way that you actually do this strategy. Right. And that's a much better approach. And I think that would be better long-term really and medium term. And if we did that, I think that would just be totally awesome. So I think this is probably like, and then like to do the NFT approach, again, now that you understand the set service implementation, like that approach is you just implement this callback function, right? And then what he's done in the NFT approach is he's created this concept of a thing called a diff set where you continue writing to something, and then once you're done writing to it, you say, I'm done writing, and then now you start writing again. And the second time that you start writing, it's capturing diffs. And so the diff state is how that works. It's a diff capturing tool. And so that rather than having a cache, he just has his own implementation of, which is really similar to what the existing kernel space one does anyways, because it's like caching diffs in its own way. But it's just a much more elegant implementation that's sort of really easy to code against. So you could sort of copy the NFT implementation and just port that over to do Windows specific logic instead of NFT logic, right? And that would be another way to do the same thing, right? I don't know how I'm not sure whether I've gone too fast or too slow or what. So but I think that the basic stuff, I think we've sort of covered it all, right?
Yes. Then I'll try to get Marius up to speed on the unit tests and see. I think, David, we can make a call maybe tomorrow to see what approach we take, if that's fine with you.
I just saw Scott popped in, but I think he's gone now. Yeah, I mean, that works. And we can do another one of these if you want to look at it again. And I think at Microsoft, y'all can huddle about how you want to do this, whether you want to.
Yes, the Dimitri is actually from Cloudbase. Yeah, we have a contract with Cloudbase to improve kproxy.
Okay, cool.
So part of it is we want to look at KPNG. So
Cool.
I don't know if Dimitri will be looking at this long term or not. We don't have a very long term contract yet. That needs to be hashed out. But once Ravanth is back, we can talk about the long-term improvements of this and looking at
Okay.
the long-term design. I think probably for now we will take the simple approach, but I'll discuss that with Dimitri. How much we can fit in, and we need to weigh the
Yeah.
options of how many cycles we'll spend on the legacy Qproxy and the next generation Qproxy. And so I was curious, how are you prioritizing like the maintenance of legacy Qproxy code base? Like, there's probably like new features being added there all the time, and like, I don't know.
I mean-
I don't want the code bases to diverge, but like, do you sync them periodically, or?
Yeah, no, the focus for KPNG right now is Sig Network kind of wants us to finish it and get it working so that we can all be working on one kube proxy. And the biggest bottleneck to that is Windows.
Yes.
Right?
Yeah.
Everything else is working. And so, it's hard because like we have one bug on IP tables related to the other stuff, but you're right. Like the longer we go and have two kube proxies, the more things diverge, which is why I just did this hacky, stupid implementation to start, because I'm like, well, at least maybe we can get this working and then move the community towards this. Right.
Right.
So that's kind of why we're in the state we're in, right? Is that like, I just wanted to at least have something that we could sort of start to hand over to the experts. That was kind of the thinking. But yeah, once we have Windows kernel space, I think we will be able to really just start converging all of the proxy logic. And yeah, you're right. There are some things that diverge a little here and there. And we're just going to have to, before we cut over to KPNG, we're just going to have to audit the code base and make sure, look at all the commits and make sure that we've ported things over, I mean, and also the expectation from my end is that the end-to-end tests are covering things, right? So I'm expecting that the hundreds of Kubernetes end-to-end tests that we run for SIG network, for network policy, for conformance, that those all have enough test coverage that we're not going to lose functionality.
Okay, and this is probably a loaded question, but assuming we had the Windows port done, like let's say even if it's just the dumb implementation of the existing legacy code, like when do you see this being adopted by the community?
I mean, SIG network is on board with it. So I think that as soon as Windows is done and passing conformance, I think that's when we get the approval on the KEP, and then it's just a matter of getting the work done and finishing the releases for it. So I think that this work could be done in one release. Like, I think in one release, we could have a KPNG alpha that anybody could run that had IP tables, IPVS, and Windows support. And as soon as that alpha came out, like I think as soon as the Windows thing is done, we could like merge that KEP, and then we could have a KPNG alpha in that release, right? Or in the following release, I think. And once that KPNG alpha was out, I think we could, in the next release after that, we could merge, we could try to merge this in tree or make it the new kube proxy and move it to beta to GA, right?
Oh, okay.
I mean, we have to follow the release process, right? But I think this basically is I think like once the Windows stuff is done, I think we can literally just, everything else is just, we can parallelize all the other work that comes after this, right? Because we can literally say, okay, let's get 4 engineers and let's just have them do this, right? And I think that'll be pretty easy because it's just a matter of moving code around and updating documentation and setting up CI jobs and so on and so forth. And that stuff can be done in a parallel kind of way,
Okay.
So yeah, the current goal is, like get the Windows stuff working so that we can really finish the KEP and have 100% confidence that everything that we care about will work, right?
Okay, yeah.
I'll end the broadcast and we can talk more.